Okay, hello everyone. This is Vikas Narune and hope you guys enjoyed the last session. So welcome back to the day 2 of this session of deep learning, machine learning and computer vision and NLP. Hope I am audible guys and you guys are able to see my screen. Just quick check. Am I audible guys? Can you hear us? Okay. Okay. And just give me confirmation that you guys are able to see my screen as well. Yeah, okay. Okay, then guys, we are good to go. So guys, just imagine that you guys have booked a journey with us for the safari. Let's say it's a jungle safari and the jungle is for the AI jungle. Okay. So all what you have to do is sit back, relax and enjoy this journey with us for next 3 weeks. Okay. So without wasting time, just let's get started. And let me just have a recap that what all we went through yesterday. So we were able to discuss the topics like what is the AI, introduction to AI, what are the advantage of the AI, okay, how AI is, what is artificial intelligence, how AI is becoming a market, what are the different types of the AI, right? So how AI market is getting popularity nowadays, how AI has produced as a services, AI as a services, right? So what are the everyday, how our everyday life is getting affected by the AI, what are the some real-time application in all the fields, and these are just some example like how we have adopted the AI in our life, and then we were able to see some amazing use cases in the different fields for the AI, right? And then we also saw why what are the advantage of the AI and what are the challenges in the AI. Then we were able to gain some understanding like how AI is machine learning is different from the AI, what is deep learning, how they are interconnected to each other, right? So if I can say AI is a jungle, then machine learning is also sub part of this jungle, and deep learning is a further sub part, right? So we were able to understand what is the difference, where to start, and we decided to start with the machine learning. Guys, agenda for today will be like where we started to understand what is the approach, different approaches available in the machine learning. So we'll try to understand what are the different main functionalities in the machine learning. Let's say what are the major tasks which you guys will be performing when you are saying that you are performing a machine learning task. So try to understand this task, and we will also try to understand and gain some insight about what are the popular algorithm for this particular task and what is the background working of this task. Okay, once we understand what are the algorithm, what is the background behind this algorithm, how they are working, then we can go ahead and understand the complete life cycle of the machine learning, like how data is getting captured and how we are pre-processing it, how we are doing a EDA, exploratory data analysis, how then we doing visualization, how we are trying to select the feature engineering, then how we are building a model and how we are able to see the model and how we can perform an evaluation on the model. Okay, that's the agenda. And then we will try to look at a use case, like I will make a walkthrough for a code where we'll try to discuss two amazing use cases. One will be we'll try to take a example in the healthcare industry where we are implementing the machine learning algorithm in order to predict the sleep disorder. The objective of this project will be to understand whether you guys are suffering from a disorder or not based on the certain information which is available in terms of the features. And then second use case, I can make you a quick walkthrough about detecting whether this particular currency is genuine or not genuine. Why I am trying to cover these two projects, because whatever the concepts we are talking about, terminologies and the life cycle which we will be going through, so you will be able to get a real-time feel that what a production grade machine learning model look like, and how the coding is part is done, how the analysis part is done, how model will build. So you get a real-time feel of how the machine learning look like. Okay, so we started with the different approaches. Like in machine learning, we are mainly having the four approaches. Major approaches is supervised learning, unsupervised learning, reinforcement learning. We also tried to saw a hybrid approach, which was called as semi-supervised learning, right? So these are popular algorithm, and these are the categories of the different approaches. We also try to understand what is supervised learning. Let me have a quick review of what is supervised learning. In supervised learning, what we are doing is we are trying to get the label data, right? If we are getting label data, we are trying to get a labeled data, right? Just like this. In this label data, we are telling machine that what are the different shapes. Let's understand this diagram that we are trying to understand, that whenever we are providing the different kind of data set to the machine, so we are trying to tell the machine that what labels are available in this data. That means we are saying, if we look at these shapes, we are saying that, okay, in this particular data set, we have a rectangle. Okay, we have a rectangle, then we have a hexagon, then we have triangle and hexagon and circle, and this information along with the labels and providing it to the machine learning algorithm. Then machine learning algorithm will try to go through the epochs and try understand and build a model. Once we build a model, we'll pass a test data set to it, and on the basis of this test data set, it will be able to give us a prediction that whatever test data you have passed, whether this belong to certain category, whether it will be able to identify what is the figure, whether it is a rectangle, circle, or hexagon. So it is able to predict that whatever data you have provided is a triangle and as well as a circle. Okay. So this is all about the supervised learning. Then we'll try to move to the unsupervised learning. In unsupervised, what is the difference? That we are not we are giving, again, we are feeding the data set to the machine learning algorithm, but we are not telling this time that what are the different shapes are called upon. Like we are telling machine learning that you only figure out what are the different data sets which are available in the database. In the data set, what are the different features available? You try to process it and give us a result, right? And then it will, on the basis of the certain feature like shape or color or proximity in terms of the distance and all, it will be able to give us the results. Okay, so that's how we provided. This time we did not give them, like in supervised learning, we were giving the labels. This time we are not giving labels, and it has given us a different groups. Like it has separated the hexagons, it has separated the rectangles, and it has separated the circles. That's how, guys. Okay. So once we understand that what is supervised learning and what is unsupervised learning, then we also saw what is a semi-supervised learning, where we are giving a mixture of the data. One, we are giving also small amount of the label data set. Let's say in this case, we are giving the red dots and blue dots, and we are trying to identify on the basis of the color here. And we're also giving some plain data set, where we are not given him what are the different labels, or let's say color in this case. Then machine learning algorithm is able to process this data, and then the basis of the data which was labeled one, it tried to mimic the same labels to its corresponding data points, and on the basis of that, machine learning algorithm is able to fill in the unlabeled data with the labeled data, and then it will be able to give us the label data set. The task over here was to identify what could be the probable labels for this data which was missing in the first place. And we gave the small amount of data. On the basis of that, it was able to cluster it, it was able to identify the relationship between the data, and then it gave us the pseudo data set. Then further we can utilize this data set in order to build any of the approach, let's say supervised or semi-supervised approach or unsupervised approach, in order to build our use case. Okay, clear, guys? So we also saw that what is called as a reinforcement learning, and how the reinforcement learning works upon that. In reinforcement learning, again, it is kind of unsupervised learning, where we're not giving the labels, and here the algorithm works on the principle of the reward and actions. Like if you take a correct action, you will get a reward, and if you take a wrong action, you will get punishment. Remember, guys, we spoke about the example that how the pets learn, or how the small children learns, because once we teach the pets to perform certain actions, whenever it perform a desired action, we try to give it a food, then it likes the food and try to remember, okay, if I perform a certain action, then I will get a food, or I will get a reward in terms of the food, and if I do not perform the desired action, I will get a punishment, right? Thus, similarly for the small children also, we always tell them what to do, what is wrong and what is right. whenever they perform a right thing, maybe we give them the reward in terms of the chocolates, cakes, and certain other things, whatever promises you make to them. And then if they are not performing, maybe you guys scold them to try to teach them the lesson, right? Not harsh one, but because yeah, in terms of the ethics, we try to teach them what is right and wrong, and that's how the child learns to differentiate between right and wrong, right? So similarly, once we are able to understand that what are the different approaches available in the machine learning algorithm. So I told you that there will be majorly three tasks which machine learning algorithm will be performing. One first task it will perform is a regression task. In regression, what we are trying to achieve is, in regression we're trying to predict a continuous value. Okay, continuous value in the sense like let's take example that I am trying to predict the sales for the coming years, or I'm trying to predict the temperature, or let's take example that on the basis of the height I am trying to predict the weight, or vice versa. These are certain examples where we are trying to predict the continuous values, and on the basis of that continuous values we're trying to solve our business case. Okay, maybe it is also take example in the education that people mostly who are going for the higher studies to the abroad, for them also there is an amazing use case which has been built up using the AI, where you guys will be able to provide the data to certain application. This application works in such a way that whenever you log into this application, it will take information like what is your CGPA, did you guys do masters, or have you already done graduation? Along with it, have you done any extra certifications? What is your age? What are the extracurricular activity you have passed? What is your score in the GRE, TOEFL? Okay, so have you guys done any extra project? And also, have you got any recommendation? Have you tried before to these universities? Okay, this kind of certain criteria you will try to fill in. On the basis of that criteria, this site will tell you directly whether you will be able to get a it will give you a prediction whether there will be what are your chances to get the admission in for the higher studies for the abroad, right? So this kind of and now the chances will be in terms of the continuous value, like what is your chances to get into certain university, right? So that could be a real use case where we are using the regression algorithm. So before we go into further tasks, so try to understand that these are the popular algorithm which are available, these 9 algorithms. So we'll try to understand what do you mean by regression actually. Okay, let's take an example. You guys are able to see the graph. Let's take an example that what I mean by regression. Okay, let's take example that we have 2 columns, X and Y. Okay, on the basis of these 2 columns, this is variable X and this is variable Y. And my use case is to understand how I can predict Y on the basis of the X. And obviously for that purpose, you will use the equation Y equal to mx plus c, right? Here, what we're trying to do is we're trying to build a statistical model where on the basis of this model, I'm saying that on the basis of X, I'm trying to predict Y. Okay. On the basis of X, I'm trying to predict the Y. Then how actually it will work? That in this case, Y will be called as a target column, right? And X is called as a feature. Okay, because we have only one column, and then we are trying to predict on the basis of the X, Y. So I will try to put it in a statistical model, and my model says that Y equal to mx plus c. Okay, and then when I'm trying to solve the problem, then I will be if I am able to understand the value of m and value of c correctly, then when I input the value of X, I will be able to predict Y, right, accurately. So in order to understand what could be the possible value of M and C, the machine tried to learn from the data. Okay, whenever we pass the different values of the X and Y, it will try to find out through processing through the different iteration, and it try to come up with the optimal value of M and C in such a way that whenever we are inputting the value of M and C along with the X value, then it will be able to predict Y accurately. So this is the this comes from the statistical side, but when we try to analyze it, how it works from the graph side, so you can look at the example here. In the graph, what we'll try to do is what machine learning algorithm does is it try to plot the data in X and Y basis. Okay. So let's say this is X-axis and this is Y-axis. So on the basis of this, they try to put the data set, plot the data set. Okay. Let's say this is our data set. We try to put X and Y values in terms of the graph, and then we try to analyze. It will try to analyze, okay, on the basis of X, okay, on the basis of X, how there is a change, in Y, okay. On the basis of X, how my Y is changing. In this case, you guys can see that as the value of X increases, okay, the value of X increasing, value of Y is also increasing. So there is certain pattern which has been built between these two values, okay, these two columns, or that is called as correlation. That means there is some relationship, and that relationship is analyzed by the algorithm in such a way that whenever there is a change in the X, there is certainly a change in the Y, but we also can understand what direction the change is happening. If you look at the current this graph, we can say that whenever there is a positive change in the X, or whenever there is a change in the X, like whenever there is a X is increasing, Y is also increasing, right? So this is a upward trend. You can say this is called as positive correlation, guys. Okay, this is called as positive correlation. So what we're doing actually is we're trying to figure out the relationship in terms of the correlation, that what is the correlation between X and Y, and if we are trying to find out the exact correlation between X and Y, so maybe I try to fit in my statistical model, which was Y equal to mx plus c. Okay, Y equal to mx plus c. This was my model, statistical model. This was my formula. On basis of this formula, I will try to predict. Okay, this formula belongs to the straight line. So what I will do is, on the basis of this data set, I will try to get a best fit line. Then you will say, what is the best fit line? Best fit line will be simply a line which will try to pass through the maximum data points. In this case, maybe I can draw a line where I will be able to cover the maximum data set. Let's say in this case, this could be a line. Okay, and the equation of the line will be Y equal to mx plus c. Now the prediction algorithm, which will do a prediction, okay, that prediction will be basis of this line, right? So my prediction, first, whatever prediction I will try to do will be based on this line. So whatever data points which are available in this line, I will try to take this line and take the prediction as the points which are available in this line, that is called as best fit line, and I will give simply a model will return value as whatever data points available. Let's say this yellow data points are our prediction, and the red data points which are our actual values. So let me try to again reframe it. So our situation here we are facing is that we want to analyze what is the relationship between X and Y, and what we decided that we'll try to predict the variable Y on the basis of the X, and how we're going to predict is using this statistical model. This statistical model, we try to find out the optimal value of M and C, which is called as slope and intercept. And once I know the optimal value, I will be able to directly put in the value of X, and it will be able to help me or give me Y hat, right? Okay, that's how. And then in the background, what it will do is it try to plot this data set, available data set on the graph, and we'll try to look at the data set and try to find out the correlation. Once I am able to see that there is a correlation between X and Y, then I can go ahead and decide, okay, I can put a regression model on it. If there is no correlation exists, means let's take example. If there is no correlation exists, means now whatever example we saw, that in that example, we were able to see that whenever there is a change in X, there was a change in Y. Okay. So this was X and this was Y. And we were able to see that whenever the X was increasing, there was a similar change in the Y in the positive direction. But what if imagine that whatever variable X and Y, if I try to plot them, they will look like this. That whenever there is a change in X, I do not see any major change in the Y. So in this case, can we say that there is any relationship between X and Y? So I don't see, because whenever there is a change in X, there is hardly any significant change in the Y. So this is called as no correlation. So there is no correlation between X and Y. But in this case, where I can see whenever there is an increase in the values of X, value of Y also increasing, the unit may not be different. Unit may be different, guys. Try to understand that unit may be different. Not exact change in the X will be able to reflect in the exact change in the Y, but the similar change, maybe a proportionate change. But at least we can understand that on the basis of the X, Y changing, this is called as positive correlation. When there is, we not see any change in X and Y, it is called as negative correlation. No correlation. And when we can see that opposite to a positive correlation, they could be also negative correlation, right? And this negative correlation, whenever there is a change in the X, the Y is decreasing. Okay. Where there is a change in the X, Y is decreasing in the negative direction. At that time also here it is increasing. And that time we can see that also possible that whenever there is a change in the X, the Y is decreasing. So at that time we'll have a negative correlation. So if there is a correlation, let it be positive or negative, but at least we will be able to frame a model. But if there is no relationship between the model, between the variables, then we will not be able to frame the model. So how we going to frame the model? Again, let me create the graph. That simply model, what model will do is it will try to create a graph on the basis of X and Y. Once we try to plot this graph, we will try to see whether there is a relationship. Once we see that there is a relationship, then we can go ahead and provide the statistical model, which was Y equal to mx plus c. And it is nothing but it is a straight line. Okay. On the basis of the straight line equation, we will be able to predict this equation. Then how we'll try to fit a straight line, and on the basis of this straight line only, okay, on the basis of this straight line only, whatever points are available, that will be our prediction. So there will be difference between the predicted value and the actual value. That is called as errors. Okay. So whenever we are trying to predict, it will be called as Y hat, and it will be different because we are not able to put a model in such a way that, and it is really impossible to put a model which will give us the exact value. Okay. So, but it will be close to certain values. So though that the values, the range in which this prediction of falling is called as confidence interval. So you guys might have already learned about it, what is confidence interval and all. So, okay, guys, someone is saying my voice is breaking. Am I audible enough, guys, to everyone? Just give me a confirmation, guys. Just 2-3 more confirmations so I can understand I am audible, everyone. Okay, guys, I think I'm getting yes. So I assume that everyone is able to, most of you is able to get my voice. So we'll continue. So what we're saying is in regression, what we're trying to do is we're trying to find out the relationship between the dependent and independent variable. What dependent variable and independent variable means, we have a certain feature x1, x2, x3, and on the basis of x1, x2, and x3, these are the feature or columns we can say. On the basis of that, we're trying to predict the Y value. And in the background, what it's doing is we try to plot the graph between the independent variable and dependent variable. We try to fit a straight line out of that graph, and on the basis of the straight line, it will be able to give us a prediction. That prediction will be very close, but it may be possible that it is not exactly the real point. So that's how the accuracy of the model will be defined. There will be difference, and what is that difference, will be able to term it as a loss function. That is difference between the actual value and the predicted value. That is called as Y hat. Okay. So that's how, just guys, I wanted to give you, I don't want you guys to understand that concept thoroughly, but the main idea behind this exercise was to what machine learning algorithm is doing in the background whenever we see saying that there is a regression algorithm which is performing. Okay. And there are different regression algorithm which are available. The simple example of the regression algorithm is a linear regression, simple linear regression, where we will be having only one variable. Let's say we spoke about x1. Whenever we will having more variables, so it will be called as multiple linear regression, because we will have a multiple columns, and out of this multiple columns, on basis of this, let's say x1, x2, and x3, we will be able to predict the value of the y. Okay, and that's how we'll in the background only. the machine learning algorithm will try to find out the correlationship, like we spoke about the correlationship, whether there is a correlationship or not. On the basis of the correlationship, we try to predict fit in a statistical model, which is y equal to mx plus c. If it is a single variable, then it is y equal to mx plus c. If there is multiple variable, then it will be having different variable added to this mathematical expression. Okay, and the basis of that, it will try to predict, and then it will try to calculate the loss. In first iteration, there will be multiple iteration, guys. Whenever the machine learning algorithm is working, it will try to perform calculation on the first iteration. Again, it will try to find out the loss, and if loss is greater, then it will try to perform same action again. Again, it will try to predict on the basis of this straight line. Again, it try to compare with the actual value difference. It will calculate the difference between actual value and predicted value. It will sum it up for an entire data set, and again it will check what is the accuracy. So it will keep on performing until unless we get a desired result. So guys, I think you guys are clear that what is regression, what regression algorithm is doing in the background. Just give me a confirmation, guys, if I am able to explain you guys that what do you mean by regression. Regression means simply we trying to predict the relationship between two variables or multiple variables to one variable, which is our target column y, on the basis of the different column. And on the basis of this different column, we try to predict it. In the background, what machine learning algorithm is doing, it try to fit a straight line. On the basis of the straight line, it try to give a prediction. So the whatever predictions initially given may be far away from the reality, then again it will go for the second iteration, third iteration, fourth iteration, and after going through series of iteration, it will be able to give us a accurate predictions. Okay, that's how the whole idea, guys, behind this showing this graph is to you guys should able to understand. Okay, so how the machine learning algorithm is working in the background. So you guys may not be able to understand the different terms which are used, like what is the loss function, which are different iteration. Doesn't matter, but I want you guys to understand in a graphical way that what machine learning algorithm is doing in the background. Okay, we saw the example, which was the first example here, which was seen in the graph, first example, where we are trying to build a model using the simple linear regression. It may be possible, guys, that whenever I am trying to build a model, okay, whenever I'm trying to build a model, in this case, this example number 2, whenever I'm trying to build a model and try to see that there is a relationship between the variables, but my relationship between the variable is present, but I will not be able to predict the relationship just by drawing the straight line. In this case, you can see that this is a straight line which has been drawn over here, but it is not able to pass through the maximum data point. Okay, if you guys can see that it is able to go through the points, certain points. Let me highlight the points. Okay, so these are certain points which are available. These are the real data points. Okay, and our machine learning algorithm, since we are using a straight line equation, statistical model of y equal to mx plus c, and when I drawing this straight line, I am not even able to reach to the close of what is the reality. That means whenever I try to do it, and there is actually a large difference. You can see there is a large difference. Maybe I use a different color so you guys can understand. So between this point and the straight line, there is a difference, guys, right? These green points and the straight line, there is a huge difference. In this case, in the first example, we will try to fit it to the reality. Okay, so we will try to close to these points, but in this in certain situation where the shape of the data is not a straight line, not able to fit a straight line, at that time what we'll do is we'll try to, rather than fitting a straight line, what we'll do is we try to fit a curved line. Okay, that is called as polynomial. What do you mean by curved line in terms of the statistical model? We saw that our first statistical model, what we did is we just took y equal to mx plus c. If there are multiple variables, then there will be x1 plus x2, right, plus x3 and so on. And then there will be certain constant slope and constant, right, like m and c. Then m1, m2, m3, similarly we go, right? So in this case, it was representing the straight line, but in the situation where the shape of my data set is different, where I am not able to predict using this straight line, what I will do is I will try to create a line which will try to go through the maximum data point. In order to go through the maximum data point, what I have to do is I have to bend this line in a such a way that it becomes a shape of the curve and it try to pass through the major data points. Once if it's able to pass through the major data points, so I will be able to minimize the distance between the actual data point and my prediction. So that's the reason that rather than putting a straight line, I will try to use a curved line in this case, right? So that is called as polynomial. In polynomial equation, how it will look like is we're trying to square or cube it depending on the shape of the data. Here there was no degree for the x-axis, right? X variable, right? So in this case, there will be square or cube. We'll try to square it, or maybe we try to cube the x. Okay, and when we try to square or cube or take it to the fourth power, then it will not be straight line. It will look like this curve, right? This V curve. And this, by using this curve, we try to fit in the maximum data points which are available in the data set, so our prediction will be accurate. Okay, guys, that's the intuition behind the regression. So in regression, we try to fit into the baseline, try to produce a baseline which will be able to pass through the maximum data points. So on the basis of that, we will be able to do a prediction. So maybe a straight line. If it's not a straight line, then we'll try to make it as a polynomial regression, which will be our curve shape line, which will be able to pass through the data. Then next thing which will come into picture will be regression with the regularization. So whenever, let's say, whenever we are dealing with the multiple features, at that time, what will happen is like, let's say my data set look like this. This is my y. This is my value I'm trying to figure out. And I have a multiple data set, multiple features in my data set. That is simply say multiple columns in my data set, right? Let's say I have 5 features. And this 5 feature, let's say one x1 value range comes in the thousands. Let's say 1,000, 2,000, 3,000, 4,000. But my x2 value, okay, x2 values in the 10, 20s, and 30s. Okay. And x3 value may be in 50, 60. And again, this could be in millions. So you guys can see that there is a there is a difference between the different column in terms of, even though these are the numerical values, but there will be obviously difference between 1,000, right? The difference between 1,000 and 20 will be very huge, right? So maybe it is possible when I'm trying to fit in this all these variables in terms of this my statistical model, my model may be biased towards a variable which is having a high value, right? Like the thousands and all. Okay, just to make you clear, maybe take an example that whenever I'm trying to predict the price of the house, in the price of the house, what all variables we can have? We can have a square feet, right? What is the square feet of the values? Then we'll have number of balconies, bedrooms, right? Number of rooms. Then we'll try to understand whether it belongs to a premises, which is a prime premise or not, where there is a school nearby, or what are the infrastructure available, right? What is the infrastructure available? So whether there is a school or not, maybe we can say 1 or 0. Okay, 1, 0, 1, 0. Whether it belongs to, whether all the infrastructure like the train station, railway station, or all the cab facility, train facilities there or not. So you can say that yes or no. Yes, cab facility, train station infrastructure, yes, no. Again, whenever we are trying to model this equation, just try to understand first whether this is a prime location, yes or no. Okay, yes or no. And then comes the how many rooms are there. Let's say rooms will be 2 rooms, 3 rooms, 4 rooms, 5 rooms, right? And what is the area in the square foot, right? Let's say I put area as a. So area will be like 1,000 square foot, right? 1,000 square foot, 2,000 square foot, 800 square foot. So when I'm trying to combine all these called as features, right? These are features. These are my feature. On the basis of that, what I am trying to do is, okay, what I'm trying to do is I'm trying to predict y, right? On the basis of these different features, right? mx1, mx2, comma, mx3, comma, mx4. Or let's say just put a statistical model that I am trying to do is mx2 plus mx3 plus mx4. Just for the example, I am just taking 4 variable, okay? And plus there will be constant slope and intercept. So this is my mathematical equation. I am trying to predict y, right? So what is my y? In this case, again, y will be the price of house, right? what is my price? Sorry for my bad handwriting, guys. So again, my what is my price, right? 1 crore, okay, 1.5 crore, and so on, right? Or 2 crores. Just take any pseudo example, right? What I'm trying to do is whether what will be my price of the house on the basis of this feature, like how many balconies are there, whether it belongs to a prime location, whether there are the transportation facilities available or not. So machine learning algorithm, whenever machine learning algorithm try to understand, it try to take the feature and try to understand that what is the relationship between all this. So when I compare 1,000 to 2, so there will be huge difference, right? There will be difference of 998. So what it can understand is it will try to give a more importance to the square foot rather than giving importance to balconies and other features. So at that time, machine learning algorithm will become biased towards certain feature. Let's say in this case, the square foot of the square foot area, because it is a high denomination term. So it will try to consider, okay, this is important feature, so I should give a more importance to this feature, square foot. Okay, more importance to the square foot of this feature. Let's say feature A. Okay, I will give more importance to feature A, and I will give a less importance to other features. So we can say our model is biased. Biased, right? It is biased towards this feature. So in order to avoid this kind of biasness, what they thought of to introduce the concept of the regularization. Okay, guys, that's why this regularization concept came into picture, because in real time, will not have a data set which will be inconsistent to the feature. All the values will be very different, like we have seen in this case, right? Some values may be in thousands, some values in maybe hundreds, some in tens and all, or maybe certain values are there which is categorical variable, right? Yes or no. So what machine learning algorithm will do, we'll try to convert these values into the numericals. Yes will be 1 and no will be 0, and accordingly it will try to replace the value. That is called as label encoding, right? So once we do this label encoding, then we'll try to bring it to the same scale. Once we try to bring it to the same scale, at that time only machine learning model will try to understand, okay, so these are the contributing factors and I should give importance to everything. So my model is not biased and whatever prediction I'm doing is accurate, right? So this way, I hope you guys able to understand what is biasness, right? Once in order to just to take care of this biasness, then introduce the regression techniques, regularization techniques, which is called as lasso regression and ridge regression. In lasso and ridge regression, what they're doing along with this equation, where we are trying to find out the loss. What is loss? Loss is difference between the predicted, let's say y hat is a predicted value and yi, let's say yi is the actual value. So what we're doing for one, if we're calculating for one instance, for single instance, it is called as a loss. So when we're trying to calculate for the entire data set, what I'm trying to sum it for 1 to n, whatever available, it is called as cost function. Okay, so try to bring out what it decided, that rather than making our model more biased, we can do something regarding the different features or magnitude of these features. Okay, so what they decided, that rather than calculating loss also, why don't we add a certain term along with this some learning factor, let's say alpha, that I will be able to take a mod of all these things, mod of all my m features. Okay, so we'll call it as b in this case. So if I am taking a mod of this b value simply and trying to put it like a learning rate multiplying by learning rate, so maybe I am able to reduce the influence of the biasness. Okay, reduce the influence of this bias. Guys, no need to understand what I'm saying, just need to understand that in order to remove the biasness, we are trying to introduce a new term which is called as regularization. And how regularization works is like L1 or L2 penalty. Okay, L1 in L1 penalty, what we're doing, we're trying to take the mod or absolute values and along multiplying it with the learning value, we are trying to calculate in the loss function. That's the only concept you should understand right now, because whenever we go into the deep in machine learning algorithms, at that time you guys able to understand how it is performing calculations. Just for the sake of understanding, we're trying to take it that what is regression, what is simple regression, what is linear regression, what is multiple linear regression, what is polynomial regression, and how the penalties or say regulation are brought into picture. Why regulation are brought into picture is to penalize if there are any biasness in the model. That's the only concept we're trying to understand over here. Okay, for that purpose they brought two concepts: lasso regression, ridge regression. Is in lasso regression they are trying to take a magnitude values of the magnitude, absolute values of the magnitude, or multiply the learning rate and trying to add it to the cost function, and the result, and as a result we will be able to get a correct or say unbiased feature. And in terms of the, whenever you can see ridge regression, along with the cost function, they have also added this alpha. Okay, along with it they are taking the square of magnitudes. In this way they are trying to reduce the penalty. This is called as L2 penalty, and this is called an N1 penalty, in order to just remove the biasness. Okay guys, clear? At least maybe in the chats I can get. Just give me a confirmation, guys. At least I am able to tell you that what is regression, how it works in the background. And whenever the straight line is not working, we're trying to put it a polynomial equation. Whenever we are choosing multiple columns, it is called as multiple regression. And whenever there is a biasness, like let's say there is a huge difference between the values of the column, we are trying to bring a let's say we are trying to bring a regularization factor. Just few more yes or no, guys, so we can go ahead. Okay, just quickly give me a confirmation in the chat box so I can understand, then we can move to the further topics. Okay, few more yes, guys, quickly. Okay, thank you very much, guys. So I think most of you are able to understand it. So whole idea was to understand what is regression and what is doing in the background. Okay, so you guys are very clear now. So whosoever ask you that what is regression, then you can easily tell us. Regression means we're trying to predict the y column on the basis of the different multiple column, like x1 to x number of xn, and we're trying to model it in such a way that I try to find out is there any correlation. If there is a correlation, then yes, I will be able to predict it. Then how I am going to predict it is by fitting a straight line or maybe a polynomial line. And once I fit it and see that if there is a difference, then I can bring a regularization techniques, which is L1 and L2 penalty. So this is all about the regression technique, right? This regression techniques are also called as parametric regression, because what we're doing is we're trying to build a statistical model y equal to mx plus c. So these are the parameters, okay, m and c and x. These are the parameters. So it is also called as sometimes parametric regression. How about the regression like decision tree, random forest? They are non-parametric regression, because in decision tree what happens is we try to find out the one dimension and try to divide the data into the further dimensions, right? And on the basis of that we are trying to predict the regression. It's also okay guys, we'll not go into detail, but just want to give a heads up, like what is decision tree. On the basis of the decision tree regressor also, we will be able to solve the use case of the regression. Similarly, if there is a one tree, it is called as decision tree. If we are combining 100 trees, it is called as random forest. And also there will be model of k nearest neighbor. Like whenever machine learning model will try to again plot the graph of the data set, and whenever a new data set introduced, on the basis of that try to find out the distance, and it will work. And similarly for the SVM, guys, whenever we are trying to support vector machine also, it's also linear let's say linear model, but on the but how it works is on the basis of the plane. So it on the basis of the plane, we try to separate the data, and whatever the data is nearest to it, on the basis of that nearest data, it will give us a prediction. Just to give you a heads up, guys. Okay, we'll try to understand classification and everything in detail in coming few minutes, quick minutes. But now I think you guys are clear that whenever we talk about the regression, so there is a mathematical expression which has been taken care, and we're trying to frame the mathematical expression, plot the data, fit a straight line, predict. Then first iteration, again second iteration, we try to calculate loss. Again going through the iteration and iteration, then it will be come up. We will be able to come up with the accurate prediction, right? That's how the other things are working. Hope you guys, I have not confused you guys, and I think I was able to give you insight, right? And we'll also talk about, whenever we talk about the classification, we'll try to understand this algorithm. In coming slides, I have covered Let how graphically decision tree look like, how KNN look like, how support vector machine look like, and we'll also try to understand neural network regression. Okay, at least whenever I talk about the regression equation or regression problem, it will be having the similar concept like this: prepare the graph, prepare the data set, straight lines or curved lines, regularization, and then make the predictions. Okay, so without wasting time, let's I think I've given enough example of the regression. So let's go to classification. The second major task which we will be able to perform using the machine learning will be classification. Now you'll say, what do you mean by classification? Classification means, again, I will be having a data set. On the basis of the data set, I'm trying to predict the different categories. Okay, different, let's say this is not good. I am trying to predict different categories. Okay, let's say category 1, category 2, category 3, and category 4. What could be the categories? Let's say whenever I am talking about the situation, when I am talking about the customers. So maybe online retail portal, maybe they're trying to identify the customers, that where they belongs to, whether they belongs to daily grocery sector, food, or whether they belongs to fashion. Okay, fashion, whether they belongs to sports category, or whether they belongs to electronics category. So these are my categories, right? So what I'm doing is I'm feeding my machine learning algorithm the data, and on the basis of this data, I'm telling it that, okay, give me a bifurcation that what are the different categories this customer will fall into. So simply, so what I'm trying to do is, again, since classification is also a supervised algorithm, I am defining the categories C1, C2, C3 well in advance, right? If you could remember when we saw the process graph of how supervised algorithm works. So we are trying to give the labels. These are called as labels. Okay. So what I'm telling machine learning algorithm that these are my predefined categories, and I want you to bifurcate my data into these categories. Or these categories could be anything like customers types, or these categories could be whether there is a fraud happened or not, there is a fraud or not, or whether customer is going to default, whether he will default or not default. Okay, default or not default. These are certain example. Or let's say you applied for the loan, whether your loan will get approved A or not approved NI. Okay, these are the categories. These are binary categories, multiple categories. This how you guys are, I think I am able to get the intuition that what could be the categories. So what happens is whenever I try to get a data using certain different algorithms, I'm trying to bifurcate the data into the predefined categories. That is classification. Okay, guys, that's a simple example. So you will say, what are the different popular algorithm? So we also see this algorithm where also present k nearest neighbor, support vector machine, decision tree, random forest. These algorithm are multiple per algorithm, which can be used for the classification as well as regression. But the techniques, the background in the background, how they works is somewhat different. So let's try and understand the first classification algorithm, logistic regression. Okay. In logistic regression, works good for the binary category data. Let's say we are able to see, in this case, we are able to plot our data X and Y. On the basis of this X and Y, I saw that there are two categories which are present. So if I am, what I will do is, I will try to fit in a line. Again, this line, logistic regression works on the equation of the linear classification. Okay. So you try to fit in a line, maybe a curved line or straight line, in a such a way that I will be able to bifurcate clearly. So I can also draw a line in this way. Okay. And by drawing this line, I will be able to bifurcate the points which are here and which are available in yellow color. Let's say take the color data, yellow color and gray color. And by drawing this line, I am able to bifurcate. Okay. So maybe this is category 1 data and this is category 2. So we were able to separate the data, bifurcate them into the categories by doing the straight line. So that's what logistic regression does, simply, and by understanding the simple meaning. Yeah, okay, but it is using the logistic function, which is called as a logistic function or logarithmic function also. Okay, so I will write you equation that it uses the function y equal to 1 plus 1 divided by 1 plus e to the power x. Okay, this is the equation it uses, right? 1 divided by 1 plus e to the power x. Okay, and by using this equation, it will try to predict the values. Now, whenever it is using the logistic regression, it is the value which will be provided between 0 and 1, guys. Because try to understand that in regression, what we're doing, we are trying to figure out the continuous value. Now, what we are doing here is we're trying to perform a classification. In classification, we are looking at linear regression, logistic regression. In logistic regression also, we are trying to draw a line, and the basis of this line, we're trying to bifurcate the data. But here, the equation used will not be y equal to mx plus c, but it will be a logistic regression equation, which is a logit function 1 divided by 1 plus e to the power x. When I am saying 1 divided by 1 plus e to the power x, this is the logistic function. Okay, this is how it looks like. This is 0 and scale. If I try to draw, this is positive scale 1, 2, 3, 4, and this is negative scale. Okay, guys. So this value of this logit function will lie between 0 to 1. Okay, in this way. So no matter what value you will pass, it will try to create this S shape, and whatever equation value of this equation, y equal to 1 divided by 1 plus e to the power x. Okay, this is the equation it will use to fit this line, and using this line, it will try to find out the probability. And we have to decide the threshold of the probability. If you see this dotted line, this is called as a threshold. Let's say this threshold is, let's say 0.06, because probability works in the values between 0 to 1. So we have to decide what is the cutoff point. If I get a cutoff point as 0.6, so I can say if I get a probability score which is above 0.6, so it will belongs to this class 1. Okay, this class 1. And if it is below that, then it will belong to class 0. Simple, guys. And that's how it will work. So it again draws a line, but equation of the line will be different, and it will give us a probability that this particular variable, what is the probability that the particular data point belongs to which class. Then we try to decide the probability. If it is more than that probability, this belongs to certain other class. Otherwise, if probability is less than that, then it will belong to certain other class. Okay, simply that's how it will work in logistic regression. Again, when we talk about the decision tree, okay, guys, in decision tree, what we do is we try to divide the data set. Okay, we try to divide the data set just like the tree-like structure. So you will say how I divide the data set. Let's take example that if I have a data set, then maybe I will try to choose first one column. Let's take example. Let's take example like whether you want to go for party or not. Whenever you want to go for a party, so there may be certain decision making which you will guys do. Okay, so whether you guys want to go for party or not, that's the equation. Okay, party. Just pardon me, guys, just for this bad handwriting. But what we're trying to understand is my goal or business situation is here, that whether I want to go for party or not. So for going for party, I will try to analyze certain conditions, right? Whether I have enough money, right? If I have enough money, so maybe I can decide to go for party. Then once I fulfill this criteria that I have enough money, so I can look at the other criteria, like whether I getting a permission for my parents or not. Okay, this is second criteria. Once I get a permission, then I can also try to decide what's the time. Let's say it's a evening time, whether it is before 10. Usually people get back by 10. Now it's not normal. Maybe people get by midnight and so on. Just take a pseudo example, but what's the time? If it's greater than 10 p.m., then obviously there will be no party venues which will be available to do. So we're trying to take a decision whether I want to do a party or not. So first criteria I'm trying to say whether I have enough money or not, whether I have a permission from my parents, and what is the time, right? So on the basis of that, I have to take the decision whether I will go for party, yes or no. Okay, this same can be problem can be solved using the decision tree. What decision tree will do is, if you look at this picture, on the first, you will try to take a column. Like we have these 3 columns, right? Decision criteria. So we try to take one column on the basis of certain formula, which is called as entropy or Gini score. On the no need to worry about this fancy term. Okay? Just try to understand this is the concept on the basis of which try to understand that what is my starting point for making a decision. Maybe I decide the starting point will be money. So first I will take money, then I will take a decision whether I have enough money, yes or no. Let's clear this and then try to understand. If I want to go for a party, so I will try to understand whether first criteria is money. If money is there, yes or no. If I have money, then I can decide on other criteria. Otherwise, I don't have money, I can stop. Okay. Then whether I have a permission. Okay. Permission, yes or no, right? If I don't have permission, again, I will be able to stop. If I have a permission, I have a money, I have a permission, then I will see what is the time. Okay. Whether it is more than 10 p.m. or not. If again, let's say it's not more than 10 p.m. Okay. So it's not more than 10 p.m. Then I can choose, okay, I can go for party, yes or no. In the end, we will have a decision, yes, party, yes or no. Okay, guys, that's how it will try to figure out based on the condition. Then you will receive again the probability score for yes and no. On with whichever the highest probability is there, you guys will be able to take decision. So you guys clear how decision tree is working? Just give me some confirmation, guys, so we can move ahead. Like what is decision tree, how it try to decide different criteria, and how try to break it into the decision making. Okay. Yes, I can say yes. Okay, guys, thanks for the confirmation. So this is how the decision tree will try to make a decision. And now whenever we are trying to make a decision, a tree like a structure, and try to make a decision making, similarly, if I combine a multiple trees like this, so it is called as random forest. So what random forest is doing is taking the help of our different multiple trees and try to make a decision making. And the basis of that, we are trying to find out our final prediction. So that is called as random forest. And support vector machine, again, same, guys. But in support vector machine, rather than drawing just the simple line, which is called as plane, in this case, this line, simple line, okay? Just let me make it very clear. Sorry. So let's say this red line. These are my data points, yellow one and gray one, okay? And what I'm doing, rather just simply drawing a line, because if I simply draw a line, take equation, it will become logistic regression. Rather than taking a line, I'm also trying to decide the boundaries. What all my boundaries will be, within which I will be able to do the prediction. So these boundaries will be defined. Okay, these boundaries will be defined, and on the basis of these margins, these are called margins. On basis of this margin, I'm trying to decide whether I will be particularly taking this decision, yes or no, or whatever categories are available. In this case, we're trying to decide, okay, so which class the data point belongs to. If a new data sets comes in, these are the categories data set comes in, and let's say our data set which has come in, okay, it's belong here. Okay, now I have to decide, okay, basis of the this line and the margin, whether this belongs to class 1, whether this belongs to is yellow class, or whether this belongs to this class. So obviously, by looking at the visual, we can easily make out that this point, which has new test data which has come in, which has a proximity to those yellow points, right? And it is far from this one gray point. So obviously it will belong to yellow class. Okay, that's how in the background try to find out the distance calculation, also trying to take a margins into picture, this margin into picture, and on the basis of that try to decide whether this belongs to class 1 or other class. Okay, in case of the multiple classification, it will create a plane or hyperplane, and accordingly there will be another dimension will also be created, and on the basis of this another dimension, let's say in this case 3-dimension data, if we have a multiple category, then we'll try to understand in this way. So it will try to create all these 3 possibilities, taken to 3 possible, and then decide what will be the probability that it belongs to what class. Okay, between 0 to 1. That's how the support vector machine will work. And k nearest neighbor is very simple, guys. What it will do in the background is it is simply calculate the distance. Let's say this is our model, and this model has a 3 dimensions, like already seen, x, y, z, and these are the 3 category of data which is available with me. One is yellow one, this one is gray, and this one is, say, blue. Okay. And whenever there is a new test data comes in, let's say new test data has come in here. Okay, this is my new data point, and my equation, the situation is that problem is that I have to classify whether this belongs to which class. Okay, yellow class, blue class, or gray class. At that time, what I will do is I have to try to find out the nearest neighbor. The name suggests k nearest neighbor. Let's take the value of k equal to 3. So it will try to find out 3 nearest neighbors for new data point. So if you can say that the 3 neighbors, out of these 3 neighbors, 2 neighbors are from gray class and 1 neighbor is from yellow class. So if I taking 3, so I will try to calculate the probability. Probability for a class yellow will be 1 by 3, right? And probability for belonging to the blue class will be 2 by 3. So what is the highest probability, guys? It will be belonging to mostly to class 2, that is blue class, right? So maximum probability, what is the maximum probability? According to the maximum probability, I will try to classify the data sets. This is the simple intuition, guys, how the k nearest neighbor works in. Depending on the value of a k can be anything, 3, 4, 5, 10. You can give a range, even range of the values you try to perform using this range, and then we will to try to see that what is the accuracy my model is returning. On the basis of this accuracy, I will be able to tell, okay, what is my k nearest neighbor value. Based on this k nearest neighbor, I will try to classify the data. Okay, that's how it works. And then comes the naive Bayes. Naive Bayes algorithm is a specialized case, guys, whether it gives us conditional probability. The formula of the naive Bayes is like probability of A given B is probability of B by A into probability A divided by probability B. A and B. Let's say there are 2 cases, A and B. So this will be the formula, and it will try to plot the distribution on the basis of the distribution. And the main assumption why it is called as naive Bayes is by it says that all the features, like we see in all the columns, like all the columns which are provided in the data set, and on the basis of this data set, we're trying to find out P. So all these features which are provided here are independent of each other. That means there is a no correlationship. Till now, what we're trying to understand is, if there is a correlationship between the feature between y and x, then we try to make a model. Now what it says is that all the features x1 to x5, whatever is there should not be correlation among them. That means x1 should not have a correlation between x2, or similarly with other columns. Then only we will be able to use a naive Bayes. And naive Bayes uses the formula of probability of A by B equal to will be probability of B by A. Sorry, let me clear this so we can correctly write this. If I want to find what is the probability of happening event A, provided that the event B is already happened, will be given by the formula probability of B by A, okay, just divided by probability of B into probability of A. Let me write it in better way. Okay. So what is the probability of event A provided B is already occurred? Okay. So it will be given by probability of B by A, okay, multiplied by probability of A and divided by probability of B. This is what simply it formula says. And the assumption is that all the features which are available in the data set are independent. That means there is no relationship between these variables. So that is, it is called naive, because in real time there will not face such situation. Maybe for certain example, let's say in the NLP, where we are trying to figure out the NLP problems, at that time the feature will not be dependent on each other most of the time. So at that time we can call it as a correct assumption. So that's why this assumption is very naive, like very childish. That's why they are calling it as a naive Bayes algorithm. So that's how the classification algorithm works, guys. Naive Bayes, k nearest neighbor, decision tree, support vector machine, and logistic regression. Okay. Hope, guys, this is clear that how the different classification and main aim is of classification is to classify the given data set, whatever data set we are having, we try to classify it in the categories, maybe single category, multiple categories, and so on. Okay, that's the main aim of the classification. Okay, and this is how the algorithms will work upon. Just the intuition, not in depth, but at least I think you guys are able to understand the intuition. Okay, so we understood what is regression. In regression, what we're doing, we're trying to predict the continuous value. And classification, second major task for the machine learning algorithm, what we're doing, we're trying to classify data in certain categories. Now there will be a third task, major task, okay, which will be called as a clustering, which is again a unsupervised algorithm. Okay, guys. In unsupervised algorithm, what we're trying to do, I will quickly go through it, guys, and I will try to explain it. I will not go into detail, but I think the graphs are self-explanatory, and I will try to tell you what do you mean by clustering. So it is again one of the algorithm. Okay, it is the algorithm which is used for the unsupervised approach. Okay, in unsupervised approach, what we're doing is, whenever we are having a data set, let's take example. Whenever, let's say this is the example, whenever we are trying to take a data set, we are not telling the machine learning algorithm well in advance that, okay, this is a category 1, the red one, and this is the category 2. We are just simply providing the data, and the basis of this data which is provided, machine learning algorithm try to analyze the feature. Maybe it will try to analyze on the basis of the size, shape, or the distance between the points. Whichever the nearest distance may fall into a certain category, certain cluster, sorry, or whichever are far away from each other will be falling into the different category, and the result will be like this. It will be able to separate the data points according to their features. Okay, guys, that is called as clustering. You guys have not told machine learning algorithm that what categories you are expecting. It is trying to analyze the feature and the pattern in the data, and the basis of the pattern, let it be any shape of data, it is trying to analyze it, trying to find out that mostly on the basis of the distance calculation, also a certain other feature, and trying to separate the data. That is called as clustering, guys. I hope that clustering is clear for you guys. So in clustering, there are popular 3 algorithms. There are at least 6 to 7 algorithms which are there, but 3 major popular algorithms are there. First is K-mean algorithm. Second one is hierarchical clustering, and third one is DB-scan, guys. Okay, DB-scan, density based spatial clustering application with noise. Okay, so I will quickly make a walkthrough for you guys, or before even we start to understand clustering, maybe I have put in some good picture for you guys. Okay, guys, this is the map. On the basis of the map, let's say we try to find out what are the probable region which is available. When I am providing machine learning algorithm these cities, okay, take the example of these cities, and my aim is to bifurcate these cities based on the distances each has having, and what I am expecting that it will be able to give me at least some clusters. Okay, or clusters can be also regions. Okay, region like north region, okay, west region, south region, okay, and the east region. So how algorithm will try to analyze it is, we try to understand from the distance calculation. Okay, if this is New Delhi, okay, guys, this is New Delhi, and from this New Delhi, if I'm trying to find out where is in the south, we will have a Hyderabad. Okay, Hyderabad. We try to find out the distance between New Delhi and Hyderabad. Also try to find out the distance between, let's say here is in west we have a Mumbai, and try to find out distance between this particular city to Mumbai and Hyderabad. Also try to find out distance between some other example, let's say any northeast country, Manipal, Mizoram, anything. Okay, so it try to understand the distance. It will try to understand the distance on basis of the Euclidean distance. There are different distance calculation formulas which are available, guys. Let's say Euclidean distance, Manhattan distance, their Hamming distance, but all they have their particular implementation or purpose for this. We strictly trying to take a distance on the basis of the kilometer. So if I try to calculate, okay, what are the distances available within these cities, and the basis of these distances, I will be able to tell you that, okay, I can cluster this particular cities as a one cluster, this particular cities as one cluster, and these cities as third cluster. How I am able to do is based on the distance. Okay, whatever distance I am having, between these cities, I am able to bifurcate them like regions, north region, west region, south region, right? Simple, guys. I'm trying to just try to correlate it with a simple example where you are able to understand that what is clustering. So on the basis of the distance, what we did is we try to bifurcate entire cities into the regions, like let's say north region, south region, and the west region. But did I tell my algorithm that I need this three region? No, it will try to figure out the region by itself, and it will give a suggestion. Okay, so these are the different region, and these are the cities which are falling with these regions, right? So that's how the algorithm works on. We try to calculate the distance, and then we'll try to figure out that what will be the group one, group two, and group three. So when we see that simply the clustering, we say that whatever data set is there, we try to make them identical data points into the different groups on the basis of the distance or maybe certain other features. So for that purpose, let's try to understand what is k-mean. Okay. In k-mean, simply what k means, like the name suggests, we have to tell the value of the k. Let's say value of the k here is 4. So what we'll do is it will try to create the 4 centers. Let's say this entire is my data set. Just don't look at the circles. Let's say it's my entire data set. Okay. In entire data set, you try to create the 4 center. Value of the k is 4. So try to create the 4 centers. Random points it will take. Okay, just like this red dot. And we try to consider this as a center. Okay. From this center 1, center 2, and center 3, it will try to calculate the distance like is shown here from all the data sets. And then try on the basis of the data set, it will say whatever the data which is having less distance from this center will try to become a part of this cluster. Okay, that's how. So whatever data set which is near to this center will be part of that cluster, and whatever far away from that, let's say this point, let's take example this point. This point belongs to this cluster 1 because it has a less distance between this centroid of this cluster, and it has a larger distance between center of the cluster 2. So obviously it will fall to cluster 1. Accordingly, it will perform first iteration. You try to take a random centroids, try to perform the distance calculation, and then create a region. In second iteration, what will happen is first they took this point as a centroid, then it will try to take another centroid. Let's take example. Draw the another centroid. Let's say in the green. It will move the centroid to this point now. Okay. Let's take these green dots as a new centroids. And on the basis of this new centroid, again, it will try to calculate the distances of all the data points, and whosoever are near to this centroid will become the part of that cluster, and accordingly. So for new centroid, again, new clusters will be formed. This calculation will go on until unless our centroid stops changing, or all the clusters where we bifurcated our data set remains in the same clusters, right? At that time, it will stop. And this is how it will be able to give us the correct clusters. So that is called as k-means. K-means means what? We try to perform the centers, value of k, whatever value of k is there, try to create that many centers, create distance calculation. Whosoever points are near to these centers will become a part of that cluster. And that's how it will keep on performing until unless it reaches to the end criteria. Okay, guys, that is k-mean clustering. So then comes the DB scan. Before even going into DB scan, we'll try to understand what is hierarchical clustering. In hierarchical clustering, what it does is, hierarchical clustering also called as a bottom-up approach. What happens is, in hierarchical clustering, let's say whatever, this is our data set, okay? In hierarchical clustering, whatever data sets we are having, let's say we have like 1,000 data points in this data set. So what it will do initially is, it will create 1,000 clusters initially. So it will consider every data point as in one cluster, and it will create 1,000 clusters like this, small clusters. Let's take an example. So all the 1,000 data points, I'm just giving example of some, so because it will not be able to accommodate here all the 1,000 data points. So what? Let's take example of this 10 points, okay? 1 to 10. So what I will do is, usually I will consider all the points as in one single cluster. So I will try to clear it, this tree-like diagram. Okay. Again, pillars. and all these my pillars will be my clusters. So whatever data, simply what I am doing is, whatever data points are available in my data set, I am telling that, okay, that many clusters are there initially. Once I come up with this clusters, individual clusters, every data point as a cluster, then what I will do, I will try to find out again the distance. Let's take the different color. So if I can see that same example, guys, if I try to consider this them as an cities, so this will be Mumbai. Let's say Mumbai. This is Pune. Okay. This is Bangalore. This is Hyderabad, and this is somewhere far is Delhi. So if I try to put all the individual cities as a cluster, one cluster, then what I can do is I can see that Mumbai and Pune, the distance will be less as compared to the distance between Mumbai and Bangalore. So what I will do, individually, I consider Mumbai and Pune as two different clusters. I try to merge this cluster into one. Okay. Because of the distance. Similarly, what I will do, Hyderabad, let's say Hyderabad and Bangalore nearby because they are part of the south. So I try to cluster them into a similar cluster, and then maybe Delhi and Kolkata. Okay, here Delhi and Kolkata. So I try to combine them into clusters. So initially, what happened is I had a 6 clusters. Out of these 6 clusters, I made a 3 clusters. Okay, because of the distance and proximity. Then again in third iteration, what I will do, I can say West Maharashtra and the Karnataka or Hyderabad having a boundary, right? Because it considered as a Maharashtra region, this considered as South region. Okay, so they are near to each other, right? Boundaries. So what I can do is I can cluster them. Again, I can create a cluster out of them. Again, I can create cluster. Once I create a cluster, the Maharashtra and Hyderabad become near to each other. No, they are not near, at least. So we can consider them as a one part, right? Then once we make this one part, then we'll try to build a bigger cluster. Which cluster will belongs to, like, taking this north cluster and combination of west and south, and I will create a whole big cluster, which will be called as a one single cluster. So this is how they will try to merge. For merging, they are using the criteria, which is called as a different criteria, which is called as the let's say distance calculations, or there are certain other criteria also which they are using. That criteria is called as linkages. Okay, so they are using complete linkage, average linkage, full linkage, or ward linkage, and so on. Linkage is nothing but they are trying to understand the difference between the region, distance of centered of one region, second region, what is the maximum region, then try to cluster them accordingly. Okay, guys, so that's how a beautiful pyramid like a structure will be built upon. That is called as hierarchical clustering. Once we build this structure, we'll try to find out what are the optimal number of clusters. So we'll try to find out what is the largest, biggest vertical line, and on that vertical line, we'll try to pass out the, let me take a different color. We try to pass a horizontal line. This horizontal line will pass through this different vertical lines. It will try to cross it at whatever points. That many points we can consider this as an optimal number of regions. Let's say in this case 3. So at 3 points it touched. So we can say that optimal number of cluster will be 3. So we can divide the entire data into the 3 clusters. Simple. Guys, don't no need to go into detail. Just overview like what is clustering and hierarchical clustering, how it is doing. Okay. So clear, guys. What is hierarchical clustering? What it's doing is initially it consider all data points as a one cluster, then try to find out the proximity based on the distance. Is also called as linkages. On the basis of different linkages, it try to combine the clusters, nearby cluster, and then make the one bigger cluster in the end. And that's how. And on the basis of that, then we'll try to find out what are the optimal number of clusters into which we can divide our data points. That's how the hierarchical clustering will work upon. Okay, guys. Then comes the DB scan. In DB scan, what happens is usually we try to the concept of the number of points is very important. That okay, so these are the minimum number of points which you want in the one cluster. So accordingly, we can understand. Like say one minimum points are 10. So what I will do is I will take any random point. Let's say in random point in this case will be this random point. On this random point, I will try to surround the 10 elements, and on this nearest element and try to create one region out of this minimum point. And for collecting the minimum point, I will decide one radius. At what radius I have to draw a circle. Okay, so minimum point and radius. Once I decide minimum point and radius, I will try to draw a cluster, and then I will try to bifurcate on the basis of the distance whether this point belong to this cluster or not. Whatever points are beyond this radius will be called as noise, and they will not belong to noise, and they will not belong to that cluster. Okay, I can draw a cluster with a different color. So it will become one cluster, and the points which beyond this below will be different cluster. That's how DB scan will keep on. Again, it will take a random another point. Let's say this and random point it will take, and we'll try to consider basis of the radius and the minimum point. Try to define new cluster. Again, it will try to define new cluster. Again, it will try to define new cluster, and it will keep on dividing the clusters until and unless it is able to give us this kind of prediction, like clear predictions. This is how it will happen. Okay, guys. Clear. And this is again advanced technique, guys, where graph based clustering, or you can say birch clustering, where it is trying to understand the probability and the distribution of the data on the basis of that it says that whatever data points are falling in the nearest distribution will be part of one cluster. That's how we're trying to cluster, because you can say previously it was cluttered and then it was able to separate the colors of the pixels accordingly. So that's how the clustering will work, guys. I hope I made these are the three major tasks what we'll be doing in the machine learning, like clustering, classification, and the regression, and what are the popular technique we discuss. Okay, guys. So let's take a moment back and try to get a reviews from you guys, that whether you guys are able to understand what are the three main tasks and how the algorithm works graphically. Just give me a confirmation, guys. And so I can move ahead and then directly take you to the process of the data science, like how data science machine learning algorithm, what is the end-to-end life cycle of the machine learning algorithm. Yeah. Okay, guys, few more yes or no's, so I will be able to understand. Graph, when someone is asking what is graph is, guys, we can discuss this later on, but just for the information, good to know, I have told you graph based clustering is not used primarily. We are using only three popular techniques whenever it comes to clustering. But I hope, guys, that I am able to make you understand what is the background. Okay, share PPT. Okay, guys, yes, material will be shared end of the day. Okay. So we did not complete yesterday. So trying to plan, we are planning to complete at least one implementation today along with this machine learning concept and life cycle of the machine learning concept. So at least you will be able to understand what is machine learning. Once you guys might wonder, okay, that the whole series of these sessions or episodes is primarily focused on. Yes, guys, FCM is missing, but I'm just talking about the popular
team. We have break for 5 minutes. Yeah, I am sharing the attendance link as well. Guys, there is a break for 5 minutes, sir. So meanwhile, please mark your attendance. I shared in the chat box. Vikas, are you facing any difficulty?
Okay, hello guys, are you able to hear me? Just give me confusion.
Yes,
Guys.
Vikas, you're audible.
Okay, thank you. Sorry for the delay, guys. So my computer got stuck, so I have to rejoin this meeting. So we'll start. Let me share my presentation again, and then we can start again. So you guys are able to see my screen, guys? Just give me confirmation, guys, if you are able to see the screen and everything is looking quite okay and I'm audible. Amar, just can you just confirm, Amar, if you are able to see presentation and hear us? Okay. So most of you guys are saying you are able to hear us, and now you guys are also able to see the presentation. Okay, guys. So what we are discussing is that we are saying what is clustering, what are the different tasks, and we've seen that there are three major tasks. One is regression, second is classification, and third is clustering. And these are the major tasks which are performed in machine learning algorithm. We also we seen what is linear regression, multiple regression, polynomial one, what are the L1, L2 penalties, and how are the non-parametric regression which are also used in the classification, how they are working. Okay, so we've seen how classification work, what are the different algorithms for the classification, right? Different classification algorithm, how they are performing in the background, what tasks they are doing, how they are plotting the data, how they are able to separate the data and perform the classification task, like support vector machine, nearest neighbor, neighbors, logistics. And we also seen that how clustering is done, hierarchical clustering, DB scan, and k-means clustering. These are the three major clustering topics which we have seen. Apart from there are also certain other criteria or algorithms through which we can perform the clustering, but we have not covered it. Okay, so and the last thing which we also spoke about the reinforcement learning, we also I hope that you guys still remember the example that how reinforcement learning works upon that whenever we are providing a data which is of mixed label and it's as is also part of the unsupervised learning, it will be able to bifurcate the data without giving any supervised labels. So it works again the same example how the dogs learns. For example, when we try to perform certain action with the dog, then we are giving him as a reward as a food, then after that he tries to learn. And similarly for the human childs, whenever they make a mistake, we try to learn from the mistake and we warn them not to repeat the mistake. And similar way these guys learns. This is also part of reinforcement learning. Okay, guys. So before we start actually, how we going to deep dive into the entire life cycle of the machine learning project, I would like to take you through this path of the machine learning roadmap, where we will try to discuss that in order to become a successful machine learning or engineer or data scientist, what are the different things which you guys need to know. Okay, So let's start and understand this slide from the very basic and beginning. Okay. Let's take example that in order to become a successful data scientist or machine learning engineer, what all the frameworks are there, what are the steps are there, what are the algorithms are there. I have put in this slide for you guys so we can understand very thoroughly and quickly. So what is the building blocks? Whenever you, guys, we are saying that we want to start in the machine learning or deep learning or AI engineer. So we need to understand that we need to have a hands-on experience with some or other programming language. In this case, let's say Python or R. So Python is nowadays mostly used in the machine learning algorithm because of its flexibility, the kind of packages which are available. It's the kind of community which is there. They are coming with the different packages for different algorithm, different packages for different purpose. Let it be visualization, data manipulation, or certain other automated algorithms which are coming into place. So that is making Python very popular nowadays. And there are also other programming language. Let's say there was a rumor that a new algorithm, a new language which will be introduced, which is called as Mojo, which will be 1,000 times faster than the Python. But still, guys, even when Julia or Scala, which are the programming language which were introduced, they were saying the same thing that Python, there will be no future by the Python, but it's not like that. In order to gain the credibility, in order to implement it, have the implementation, in order to build that kind of community, it takes years and years, and then it become a stable version. So Python is pretty stable language. Along with it, also R is also stable, but mostly R is used into the statistical modeling and also for the research purpose. So both is okay, guys, but we need to understand that you should have at least one language through which we can implement the algorithms which are available. Let it be a machine learning or deep learning algorithm. So first building block or first thing where you can start will be the machine learning algorithm. Machine learning algorithm will be the programming language. Let it be Python or R. So we start with the Python. Okay. Once you guys understand Python, try and see, guys, that people say that you need to be very good at Python. It's not like that. If you might have seen that the job description which comes up nowadays into the machine for the machine learning engineer, AI engineer, deep learning engineer, rather than telling the certain other requirement, they might have also directly told that whosoever is very good at Python, please, we will only recruit that person. It's not like that, right? So Python is a programming language which is necessary in order to implement, but we need to also understand that along with the Python, you need to have a hands-on certain other areas also, just like the statistics, okay, or certain other knowledge, industry knowledge also. So we'll discuss one by one what is knowledge is required. But there is a popular misconception among the people that whosoever is good at Python will be good at machine learning or data science. Data science. It's not like that, because you guys have seen the popular algorithm. What are the popular algorithm? What are the major tasks? So you guys need to understand very thoroughly the concept of the algorithm and how they are working. What are the calculation they are performing in the background? Once you understand this algorithm, then only you will be able to decide or take a judgment. Okay, for this particular business case, what will be the algorithm you guys are implementing? Whether you are going to implement a certain algorithm, or you're going to implement the mix of all the algorithms. Okay, that's how. So first and foremost thing, in order to become a data scientist or machine learning AI engineer, you need to understand a programming language, maybe a Python or R for this instance. Okay, once you understand this Python or R, basic programming functionality is required. You don't have to create, you don't have to be extraordinary with it, but at least you should be able to implement the concept which are there in the machine learning using the Python programming language. That is the minimum their expectation, guys. Like, let's say you should be able to at least manipulate the data, how to bring the data, how to manipulate the data, how to create the different visualization in the data, then how you are going to assign the different Python algorithm in the Python. No need to create any algorithm, guys. These algorithms are already available in terms of the packages. Let's say a scikit-learn or scipy packages, which are dealing with already dealt with this algorithm. These algorithms are already built, but you need to understand how to import these different packages, how to use them. Okay, that is what expected in terms of the programming language. Then, guys, you might have seen in machine learning, or let it be deep learning also, mostly we are using the concept which are there in the statistics or algebra, like let's say linear regression, multiple regression, loss functionalities, or you can say mean, mode, medium, measure of dispersion, or certain other concept like hypothesis testing is there, or we seen like a naive-Bayes algorithm. It is trying to create a probability, a conditional probability. On the basis of the conditional probability, is try to bifurcate. Okay, even you've seen any machine learning algorithm class used for the classification. They are not giving you directly classes except for the SVM, which is directly gives a class directly, because it is a probabilistic algorithm. It directly give you a class to which class the data set belongs to, whatever prediction you're doing. But for all the other classification algorithm, and they will give you a probability that what is the probability that particular data set belongs to what class. Okay, so you need to be thorough with the probability concept, basic statistics concept, and even in terms of the calculation, whatever calculation, distance calculation is there, because we are mostly performing the distance calculation, right? In terms of the distance calculation, in terms of the classification, clustering also. So guys, statistics, there are certain topics in the statistics. Have to be expert in statistics? No, but at least you should be thorough with the certain concept, like what are the measures of mean, dispersion, variation, standard deviation, what is hypothesis testing, what is regression, what is correlation, and what are the different probabilities are there, continuous probability or discrete probability. I think this much is enough for the beginner to understand. Then once you are able to understand, then once you are able to gain the insight in the statistic, then what you have to do is you will be dealing with mostly the data set, structure or unstructured. What do you mean by structure? Structure means, guys, we are getting data in terms of the tables or spreadsheet, right? So that is called as structured data. And unstructured will be like text data, images, videos, and all, right? So you need to understand how to deal with the data. So most of the time we have to deal with the data. You have to analyze the data. You have to understand how the data set is available. Are there any missing values? Do we need any transformation in the data? How to manipulate the data? How to handle with the NA values? How to look at the different values which are available? Let's say outliers are there, missing values are there. How you are going to convert the numerical value to categorical values? This kind of manipulation is required. We also spoke about if there are different features available, right? Feature engineering is entirely a different topic, guys. Entirely different topic means it is there are people have introduced a different entire course on the feature engineering. Like Google has a certification in the feature engineering, which I have learned a few years back, that their entire course is designed only on the basis of the feature engineering, where they will be able to tell you that what are the feature, how to handle the feature. Because sometimes what happens is whatever data set is available with you guys, out of the data set, existing columns, data set in terms of the existing columns. Let's say I have 10 columns. So whenever I build around this 10 columns data set, it is not possible to get the reliable predictions. So what I have to do is sometimes I have to merge these columns together. I have to create a new columns out of this. Okay, or I have to drop certain columns. I have to bring forward certain columns. Like we spoke about the influence of the certain columns on the machine learning algorithm, where it is biased towards certain feature. So these kind of things comes into feature engineering, like how we choose a column, how we transform the column, what we are going to do with this column, and how we can make it in a structured or reliable or quality format, so that machine learning algorithm will be able to consume it directly. Okay, so once we are able to create the feature engineering, so we have to choose the features, right? What do you mean by feature selection? Feature selection means what, guys? Let's say you guys might be aware that in real time, whenever we are dealing with the data, there will be at least 1,000 columns, 500 columns, which will be available, right, in the data set. At that time, it is not possible to even look at this relationship, because I told you what we are doing is we are taking a data, we're trying to understand the relationship between data, and we are trying to plot this data, right? Once we plot this data, then we will be able to understand, is there any anomaly in the data or not? Once we see that there is an anomaly, in order to perform that even anomaly or data visualization, we need to select the features. Okay, so for human mind, it is really difficult to analyze a feature between 3D or 2D, right? So if let's imagine you have 500 columns in your data set, then you have to check relationship between all the columns and the target column, right, which you are going to produce. Now, this is humanly impossible, right? Because in order to even analyze, you have to create tens and thousands of graphs, and you have to keep on understanding the relationship between, and somewhere between you will get lost, right? What is the relationship, how it is. So what they decided, that is there anything we can do around it? So they said that, okay, let's introduce the feature selection technique or dimensionality reduction techniques. It's also called as. Let's say that in your data set, there are 500 columns. So by using the dimensionality reduction technique or feature selection technique, you will be able to understand whether all these 500 columns are necessary in order to build the machine learning algorithm. Okay. So if all the 500 are necessary or not, we have to check this thing. Or can we merge some columns together and reduce it? Or are there any certain columns which are correlated to each other? If they are correlated to each other, so we can use only one of them. Or there may be certain columns which are not making any impact on our prediction, right? So this could be certain possibilities within data by choosing this kind of thing, or certain other dimensional reduction technique like PCA and all. So we can bring down these 500 columns to, let's say, 50 columns. Okay. So without changing the meaning in the data, guys, this is also important that whatever the underlying pattern is there in the data, it should not change accordingly, right? So we have to make a calculation in such a way that reduce the dimensionality in such a way that whatever the pattern is there in the data is lying, and this pattern is not lost somehow. And without losing the significant information, we are able to bring down the number of features to the certain important features. So that's what is called as feature selection. So there are also a certain algorithms which we'll be using in order to perform this algorithm. You need to understand, and it is always better because let's see, if you try to build a model with 500 columns, then try and imagine that whenever a machine learning algorithm will try to find out the distances, how many lakhs and 10,000s of competitions it have to do, computations it has to do in the background, rather than taking just 50 columns and performing the computation. So look at the speeds also, guys. Like you can save on enormously on the speed as well as on the scalability of the model. So that's why this feature selection is also important. Once you are able to understand what is data, what is Python or R, once you understand the statistics, and then you try to understand visualization available, how to select the feature. Once you are able to do all these things, then you have to understand the algorithms in machine learning. Like we see in three major category of algorithm, like supervised, unsupervised, reinforcement learning. So there's semi-supervised there, and out of that, how we perform the major tasks like regression, classification, and clustering. So once you able to get it, then you will be able to reach to this stage. And once you are able to implement the different algorithm, even guys, we also need to understand there are certain packages which are available for the visualization. Let's say Matplotlib is there, Seaborn is there, Plotty is there, certain other packages also coming up every day. Then you need to understand these packages will help you to perform the manipulation, perform the graphical visualization in the data. Also, there are certain very famous packages like Pandas and NumPy, using which you will be able to manipulate the data. Like I said, using the NumPy and Pandas, you can perform a similar thing, which you guys might be able to do it using the SQL like languages, right? To select the data, to drop certain columns, to sort the data, to analyze the missing values, just to group the data, and make certain manipulation which is required in order to build the different algorithms. Once you are able to, you are through with this Panda, NumPy, and certain other data visualization packages. So you guys will be able to go through the EDA part and graphical representation part, which will help in feature selection, feature engineering, get the data ready for the machine learning. Because guys, the robust prediction is only possible when we are feeding the quality data to the machine learning algorithm. Because machine learning algorithm will simply take the data which you have provided, and we try to find out the pattern, perform the distance calculation, parametric calculation, and it will give you a prediction. So you guys want a model to be very robust, then you have to do, what you have to do is you have to provide a quality data. You have to provide a data in such a way that the pattern is not lost when we do a feature selection or feature reduction. Once you are able to do a feature selection, feature reduction techniques, dimension reduction techniques, able to manipulate data, bring it to certain format, then you can, what you can do is you can apply the machine learning algorithm, different algorithm, right? So we also understood what are the different algorithm which are available, right? In order to perform the task. Once you are able to apply the certain machine learning algorithm, then it may be possibility that whatever normal algorithm, classification, regression algorithm are there, they are not able to perform for the complex data. Then you need to understand certain techniques of ensembling techniques, guys. Ensembling technique come on the top of the normal machine learning algorithm. What is ensembling technique is that Let's say I've given an example that boosting. Boosting is there, bagging is there, and stacking. There are three types of ensemble technique. One is bagging. Okay, bagging. So bagging, boosting, okay, boosting, and then comes the stacking. Okay. So bagging, boosting, and stacking. Okay, these are three techniques which are available. And what we're doing is the whole concept behind this ensemble technique is that rather than using a single model for the prediction, we are trying to combine the different model. Like if you could remember, we have seen the random forest where we are trying to combine the different multiple decision trees together and then try to predict the algorithm. Similar concept is adopted, and there this is called as an ensemble technique where we are trying to combine the results and to different try to combine the different models, and basis of these different models we're trying to combine the prediction power of this model, and we're trying to get the predictions. So rather than using one single model, I'm using multiple models together parallelly. I'm training on the data and trying to take the result, and out of this result whatever is the maximum probability I will go for that result. Okay, so these are the some ensembling techniques. So XGBoost is there, AdaBoost is there, bagging is there, stacking is there. So these are some advanced level of algorithm which you might use as per the complexity of the algorithm. Once you are trying to apply this algorithm, you need to understand also the parameter tuning. Like parameter tuning means what? Let's say you are doing a bagging. In bagging, what you're doing is we are using the multiple trees, right? Let's say we are using 10 trees or 50 trees. In 10 trees or 50 trees, you need to understand like what will be the root node, how many root nodes you're trying to achieve them, what will be the depth of the right, what will be the depth of the tree, like how many layers will be there in this tree, right? Trying to draw a tree, so how many layers you will go down in this tree, right? All these things you need to understand and give a parameters tuning, right? In case of the clustering, you say we have a k-mean clustering, right? In k-mean clustering, what could be the optimal value of the k? Even k nearest neighbor classification algorithm, we have to find out the optimal value of the k. We saw in dbscan that we need to understand the minimum point and the radius while we create the clusters. So these are the parameters which is called as hyperparameter tuning. So according to the business situation and according to the complexity of the problem, you need to do hyper tuning of the parameters. First, what you have to do, you should be aware of the programming language, basic statistics concept. Then we have to do a feature engineering, feature selection. Then you apply normal machine learning algorithm. Still, if you're not able to get a result, then you apply ensembling techniques. While applying the ensembling techniques, even in the basic algorithms, you do a hyperparameter tuning. Whatever hyperparameters tuning you do, then we have a certain concept called as cross validations. Grid search algorithm. What they do is a grid search algorithm, and they will be able to give a optimal value of the parameters. Okay, guys. So what do you mean by optimal parameter? Like I said, if I am using ensemble technique where I'm using the number of trees, okay, number of trees, and what will be the depth of the trees, number of trees, how many number of trees I will use, okay, number of trees. So let's say 50 trees I want to use, let's say 50 trees, or I want to use 60 trees, or I want to use 100 trees. So all these parameters of values are that you have to decide, right? Once you are able to implement, what you can do is you can implement, take a value, like say I will take a value of 50 algorithm initially. I will take 50 decision trees, and I will be able to build a model, and then I will check the performance. And again, I will say, okay, the accuracy is not there yet. Only accuracy I am getting is 95. So let's go back and change the values. Rather than doing this manually, there are certain algorithms which are available. Let's say a cross validation algorithm, grid search algorithm. What you can do is in that algorithm, you can directly say, you can give the parameters a range of values. Let's say number of trees. Number of trees is the parameter. So you can give a range like right from 10 trees to 100 trees. This is the range I'm looking for. So please perform the algorithm on these iterations and give me the accuracy. If I'm able to satisfy the criteria of the accuracy, then I will take the optimal values out of it. So that entire headache of the iterations will be taken care by this kind of grid search algorithm and cross validation algorithm. Okay, guys. So you understood how layer by layer we have to take care of the machine learning algorithm. So first we have to understand programming language, then stats concept, feature engineering, then we have to apply the algorithm, advanced algorithm, hyperparameter tuning. Even for hyperparameter tuning, there are certain algorithms available where you providing the range of the hyperparameters and it's giving you optimal value, like what could be the optimal value for particular accuracy level. And on the top of it, right, guys, you have to be at least should have a certain knowledge about the framework of how to create the APIs or a web application, because whenever you create a model, that model has to be consumed by the user, right? So how user will be able to consume this model is using a Flask application or any web application, right? So that's not a job of the data scientist, right, guys? In some better organization and MNCs, there will be a separate team, backend team, which will be taken care. But if you go to any startup, at that time you will be doing the normal basic Flask application using which you will be able to create the APIs. Then once you create these APIs, you will be able to expose this API to any particular website or cloud platform where the user will be able to access your model, right? So that's why these things comes into picture. So no need to explain what is Docker, right? As there are many people who are from the computer science background are already knowing this. So we have to, whatever application nowadays are created, all these applications are based of the Docker implementation, and images are created. Docker, what is Docker? Docker is like, let's say, a separate room where all the dependencies and software packages will be created in forms of the containers. And I will directly ship this entire container to a person whomsoever is the user. So whenever he tries to run this application, all the dependencies on all the software requirements will be there available with him. So he will not face any difficulty while running your application. So that is, in layman's term, you can say Docker or container. So you have to provide whatever application you are creating, model application, machine learning application, you have to containerize them and then expose to the API. And then once you are able to create the API and expose it into a Docker format, then you can choose a cloud platform or web server wherever you are you want to integrate it to the existing servers or existing legacy applications where you will be able to use this model. So this your model will become a part of the services of an entire microservices which may be available. So that's how, guys, the entire path will be for the data scientists. So what is important? So stats is also important. Programming language is important, but you have to understand the programming language in terms of the situation. Okay. So a lot of the situation, according to the situation, you have to understand. Okay, guys. So I think, guys, we already passed our timing. So I hope you guys enjoyed this session and I was able to tell you guys what is the path and how the different algorithms works upon. So maybe I thought we will be able to cover implementation today, but maybe tomorrow we'll start with the directly looking at the life cycle and implementation, and we'll directly start with the deep learning. So what is the deep learning? What are different approaches available in the deep learning? What are the popular algorithms? Okay, and then we'll try to learn about the different neural networks, what are different architectures, and we'll try to create one neural network on our own as per our architecture. Okay, guys, I think hope this all the agenda is clear for coming days and you guys enjoyed it, right? So I would like to conclude, guys. Thank you very much for your time, and then see you in next lecture. Okay, guys. Thank you, guys, and just goodbye.
Yeah, thank you, Vikas. So team, I already shared the attendance in the chat box. Please mark your attendance and then you can leave the session. So we'll meet you on tomorrow at same time. Okay.